fan on the fan on
There's no last writing change now. What is it that you're writing right now? Abhishek has not come on. Vedas also has not come by. Devanshi is here. Me. Ruturaj is there. Sun. Yes. Kartik is there. He was not there. Mera. Asta is there. Ruju is there. Divya is not there. We got Akshita and Divyanshi. Okay. We are doing the lenses, right?
Yes.
I've given you some work to do. Yes. Loss of refraction
Refraction and that glass lab.
and the glass slab. Can I just have a look at the diagram, please? You keep your notebooks on the table and just come around. Keep the diagram on the table. No diagram. Then why did you say yes, ma'am? Sorry, no. Homework is homework. That is only for you. Right away, I can make out that there's some mistake in the diagram. Diagram has been given for practice. Where is the dotted line? No, not that. Ah, yes. Homework not done. It should be a dotted line. It's not a straight line.
This one.
Obviously. The diagram is wrong because the fraction taking place. The diagram itself is wrong. Diagram please. Is there a labeling? Is that a straight line? Is there no refraction taking place? The entire thing is wrong. You get a 0 for that. Twice. Just please me. Glass lab. I'll ask you to draw the glass lab.
After practice,
Not done, not done. Those of you who have not done have to do yes. I asked you to repeat it. Will you do it twice? Yourself also, sorry. Is that a homework or what we did in the class? Walking. Yes, that's right. Yeah. Homework or what we did in the class? What are the homework? Please do. The homework or what we did in the class? Twice. What about you, Vinay? Do it with a scale. That's wrong. That's wrong. Nothing to be done now. I've given it to you for homework. It means it's home work and for practice. What about you, Nobana? Fine. Why don't you sit somewhere else, please? Boys and girls, the idea of giving you the idea, I want to check your homework, class lab. The idea of giving you homework is that you draw the diagram properly. Okay? And last page. I want the first page. I come. Here, you can sit here, no problem. You can sit here. No problem. Right? And the idea that there is a refraction taking place when light enters the glass slab. Pay attention once again. So when we are talking about a glass slab and when we have incident light, pay attention to the way we draw because there are so many mistakes. And that's the reason why I asked you to do the homework so that you don't make any mistakes. At the point of incidence, when we draw a normal, this happens to be the angle of incidence. Okay? Angle of incidence is in between the normal and the incident ray. So if this glass slab was not there, it would have continued in a straight line. Why am I putting a dotted line? Because it's not a straight line. It is assumed that it is going to continue in a straight line. Is that okay? So there's no refraction here because the dotted line is showing you the way light travels. Now when it enters, obviously it is from a rarer medium to a denser medium and it is bending towards the normal. Okay. Now here once again, when we look at the refraction taking place, this is going to be the angle of refraction. Correct? Immediately you can make out that your angle of incidence is more than the angle of refraction. Okay, so this bending has to be very clearly seen in the diagram. Otherwise teachers will put a cross there. Is that obvious? Yeah, did you get it? So please show it. And very important for you to draw this arrow to show that it is a wave which is still traveling. So the moment it comes to this point, once again there's an interface. Now what is happening? It's coming from glass, which is a denser medium. Once again it is coming out to a rarer medium. So we are going to draw a normal here. Normal is nothing but a perpendicular to the surface. Now how is it going to bend? Is it bending towards the normal or away from the normal? Away from the normal. What happens to the speed of light now? From glass it's coming to air. So what's happening? It is increasing. From glass, which is a denser medium, it's coming to air, which is a rarer medium. Therefore the speed of light will increase. So it's moving away from the normal. So now it is going to come out this way. And very important to see that this dotted line that you have drawn and this emergent ray will be parallel. Is that okay? All those things should be very clear in your diagram. Otherwise you'll get a 0 children. Okay?
So this is the dotted line.
That is the dotted line. Is that okay? So when we have this is going to be angle of emergence. Why do we call it as emergence? Because it's emerging out, it's coming out. And what do we mean? See there, once again we see that angle I is equal to angle E. Angle here, if it is 45, this will also be 45. Have you followed? Okay. Now if you do this experiment in the lab and you will have angles of I, you will have angles of R. So what is your refractive index? What is the formula? Refractive index is equal to what?
Sine of angle.
Sine of I, yes. So refractive index mu is equal to sine I divided by sine R. Can you follow? So we need to have I and R. You can get it from this one. And therefore, refractive index is with respect to a pair of media. When I'm saying it is a pair, that means now it is of glass with respect to air. Okay. So here it is glass second media with respect to the first media. So this is the first media, this is the second media. Okay. So when you're talking about this process, if it is coming from glass to air, then it is going to be the inverse of it. Did you understand? The value of mu will be inverse. So for any given pair of media, we find that the refractive index is going to be a constant. Virat, tell me now, there are two laws of refraction. Tell me the first one.
The incident rate,
No, tell me. Don't look into that book from here.
the incident, no, I have not remembered it.
Neither have you done your homework.
I'm activity.
No, don't give me excuses. I forgot, I accidentally brought this book, I didn't bring that book. When will you grow up? When will you learn to be responsible? How many of you know the two laws? That's all. I'm sure. What happened? Nobody's confident. Put up your hand. It's okay. At least you know something about it. Yes? Yes? Only 2, 3? That's all? Come on, you tell me now. First law.
The incident ray, refracted ray.
And reflected ray and refracted ray.
The refracted ray are interface
In the interface.
are at the normal to the interface of two transparent media at the point of incidence.
Thoroughly confused with all the words. Thoroughly confused. Come on, Abhishek.
First law.
Ah,
The refractive ray, the incident ray, and the normal lie on the same plane
Ah.
During refraction.
okay. Basic point is these three. That is the refracted ray, the incident ray, and the normal lie on the same plane. When at and where at the point of refracted incidence. Okay, at the point of incidence, they are all lying on the same plane. That is what we have to tell. Can you recall the second law?
The ratio of the
For a given pair of media and also for a given color. Snell's law. Okay, so that's also fine. Learn it up, children. You're going to get a test now immediately. Why are you waiting for me to tell you? The moment we finish a chapter, there's going to be a test. You know that. Okay, and make use of this time because you don't even have school now. Okay, so double up your effort now because it's going to be helpful for you. Once the school starts, again, all the subjects, everything will start together. It's going to be very difficult for you. I know it. By August, September, it's going to be very difficult, very tough. So make advantage of this time which is available. Do you realize what I'm saying? Has anybody bothered to go back to the test that you've already finished, chemistry part 1? Have done. You have to. Don't tell. I'll ask me to, keep on telling you. It is up to you to do it. Okay. Test on this coming up. Next week, same time, I'll give you a test in the class. Follow what I'm saying? We are almost completing this chapter today. We are finished with the ray diagram. See what we have done in class last time. Ray diagrams are complete. Convex lens, concave lens. We have finished. Very good. And another thing that I have given you was to differentiate.
Concave and convex.
Very good. Okay. So now that part of it is
You will
done.
be after the sign convention.
Yes. So that's basically nothing but your Cartesian signs, okay, or sign convention. Now, since we have already completed sign convention for your mirrors, it's going to be pretty easy for you to understand the sign convention. Remember what we were talking about, a lens. What is a lens? It's a transparent, material from which the light can pass. So it can be glass, it can be clear plastic, it can be water, right? Any of these can act as a lens. So you have a convex lens, you also have a concave lens. So a concave lens is thinner in the middle and it is thicker at the edges. So let's talk about the sign convention now. Once again, we are talking about the y-axis and the x-axis, and this is your point of origin. So if I'm going to talk about a thin convex lens, just as we have spoken about, we have got a left-hand side and we also have a right-hand side. Remember that the object, if you look at any of your ray diagrams for the convex lens, where is the object going to be placed? Left-hand side. So all of us know that the object is always going to be placed on the left-hand side. Your object distance is u. So will it be positive or negative? Negative. So u is always going to be negative and not from the edge. Where is the measurement going to be? It is
the
from
optical
O.
center.
Okay, from the optical center, from there. So the measurements that they're giving you is always from O. So that's going to be your object distance. This is going to be negative always because object is always going to be kept on the left-hand side. Now, where is, how many figures do we have for convex? 6. Out of the 6, the first 5 are
Real and
real and inverted. If it is real, where will it form?
Left
This side or this side?
Left-hand
Yes,
side.
and good.
Sorry.
It's going to be on this side, right-hand side. So you will have something like this. Okay? So if the image, what type of an image is that? It's a real image. If the image is real, then your measurement is going to be V and it's going to be positive. Did you understand? I'm not talking about the height, children, don't get confused. It's not height. It's the distance. So the distances are always taken on the x-axis. Now, look at your diagram for position number 6. Look at your textbook, notebook, wherever you have done. Where is your position number 6?
On the left side.
What type of an image is that?
Virtual and
So it's a virtual
And area.
and erect image, right? So here, right? So obviously you will be getting a virtual and an erect image. It's going to be somewhere like this. So if your image is virtual, V, what will it be? Positive or negative?
Negative.
It will be negative. Did you understand? So these are the crucial things that you must learn to pick up when we are doing our sums. Okay, they will tell you that it is a virtual image formed. Then immediately you must know virtual. Okay, so it's going to be formed on the left hand side, and therefore the value I have to take it as negative. Is that okay? Okay. Now focal length. What about F?
2 of curvature of center.
Correct. Okay. So 2F is equal to C, but I'm asking you F. Is it going to be on left or is it going to be the
Depending
right?
on the mirror. No, on the left hand side.
What is this we are talking? Not mirror. It is a
Left-hand
convex
side.
lens. Look at your diagrams. Where is F?
On both sides.
Yes, it is going to be on the right hand side. You remember the very first diagram that we drew? What happens here? You have a ray of light, it is passing here. So F is going to be here. Look at the first diagram that I've given you. Ray of light coming from infinity. Okay? Where does it intersect? It is intersecting at F. So your F is going to be somewhere here. Okay? So now this is going to be a focal length. Tell me now, focal length, is it going to be positive or negative?
Positive.
It's going to be, focal length is going to be positive. Is that okay? Here, take it up. Take it up, quickly. This is going to be very useful if you can remember your U, V, F, real image, okay, virtual image. Sketch it out quickly, don't waste for it. Don't waste your time. You have not done your homework, Mubina? Okay, glass slab and this one. Do it twice. Okay. See, arrows are not there. So here,
I did this.
show your
Yeah.
2 times. You've already done now. You're sitting in the class. Draw the arrows. How do I handle which direction? These are not parallel. These two should be parallel. Make sure they are.
Scale है कितनी?
Let's touch it.
सारी है.
Can we do it without talking, please? Yeah.
There are so many words for this.
Meena ma'am came and then asked and all that. As soon as we finish this. How many of you from, yeah, how many of you have started off with electricity chapter? In school. In school. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. As soon as we are done with this, I'll start with electricity. Okay, that will help you.
We also have a
Given it?
light is not going to come, only electricity and magnetic effects. These two.
And in chemistry, what have you started? First chapter.
First and second.
Second
First
of
chapter
the
is completely
First chapter.
First chapter is completely.
never mind. We have completed, second is also completed for us. Okay, okay, now let's go. Let's complete this one. Sorry? Yes, any measurement, whether it is F, okay? This distance is going to be F. That? The moment we have completed it, now we are going to start and see how we are going to explain for a concave lens. What is the difference between small f and capital F? What is capital F?
Focus.
Focus. Small f is
Focal
length.
The distance between
Okay.
the focus.
Yes, that's our length. Leave him alone.
Ma'am, but we are taking F1 also, right?
Okay.
You're saying that focal length on the right side.
See, we are assuming that this is going to be a symmetrical lens, which means to say there's one sphere on this side, there's another sphere on this side, and both of them are the same. That's a
Same
symmetrical lens.
With the same radius.
Yes.
So ma'am,
So the first diagram is what is going to be effective for us. What is the first diagram? Is when the image object is at infinity and you have the rays coming and meeting at a point, that will be your F. So that's going to be your F2. Okay. Is everyone ready? Now, we are going to see for a concave lens. Okay. That's your O, optical center. Pay attention. Where do we keep our object? Left or right? Yes or no?
yes.
Look at the diagram. First of all, look at your textbook. How many diagrams for concave lens do we have? Only two. Only two. Right? Where do we keep our object? On the left hand side. Okay? So it's always going to be kept on this side. So U is going to be negative. Okay. Shh. Okay. Now look at the first diagram of concave lens. What type of a lens is that? Diverging or is it a converging?
Diverging.
Diverging. So if you look at the very first image, you will have a ray of light moving away. You will have another ray of light.
Moving away.
Okay. Once again, the refracted rays are all moving away. But if you extend it behind, it appears as if it meets at a point. What is that point?
Focus.
F. Okay. So where is your F now? On which side?
Negative side.
Yes, it's on the left hand side. So your F is going to be here. Correct? So your F is also going to be negative. Now, what type of an image do you have there? Is it a real?
Virtual.
Always a virtual. For the two diagrams that we have, both of them are going to be virtual image. It's going to be formed somewhere here, somewhere here. Okay, so V is also going to be virtual, negative. Got it? So for concave, there's not much of a confusion. All the three of them are going to be negative. Come on, quick. Done? Please. No, he will not ask. He will not ask. And don't reflect. What did you write? Confidence done? What is this that you have written here? Image, virtual, focal length. Where are your plus sign, minus sign? Why should you take it out from me now? Didn't I put it up on the board? This is too much of a spoon feeding going on. Have you followed the concepts? Clear? Right. Now, I'm going to discuss something that's not given in your textbook. Pay attention. Ready? I'm talking about virtual images. Okay, you can take the help of your textbook. There are two positions. One is for a concave lens and the other one is for a convex lens. Correct? So you will have Are we getting virtual image in concave as well as in convex?
Yes.
Okay. Now look at your textbook carefully and tell me what could be the difference in the image. What type of image? I want you to concentrate only on the virtual image of a convex lens and a concave lens. Look at the diagram and tell.
Concave lens are very possibly another concave lens.
What, can you find some difference?
The FH form is very small, but the convex lens is very big.
What is width? Yes, what is the answer? Can you find any difference? Look at the image. Look at the diagram and find out. Is there something that you can find out? What is the difference between the virtual images formed by a concave and a convex lens? Where is the virtual image? At least that much you should know. Look at the diagram, he does not even know where it is.
And the size.
Look at that.
Size.
Correct. The difference is in the size. Okay? So for a convex lens,
It is highly
what type of an image is it?
Highly
enlarged.
Enlarged, because this is what you're using as a magnifying glass. Okay? So it is highly magnified. So the virtual image formed by a convex lens is highly magnified.
and normally enlarged.
Okay, sorry?
It's normally enlarged.
Enlarged, it's always an enlarged image. Okay? Here for a concave lens, what do you find?
Highly
It is small. Okay,
developed.
it is definitely much smaller. Smaller than the, okay, it is smaller than the object. Will you remember this?
Yes, ma'am.
Okay, so such type of tricky questions sometimes could be asked. It's not specifically mentioned, but by looking at the ray diagrams itself, you can remember. Should I tell you to copy it down, gentlemen and ladies? Quickly. These are some of the points which I'm making you write so that you remember. Done? Next thing we are going to discuss about the lens formula. Is it similar?
Yes, ma'am.
Okay, is it different or it is same?
Almost same.
Almost same. Okay, once again, are you all done?
Yes, ma'am.
So when we are talking about a lens formula, once again we know that we will be talking in terms of object distance, image distance, and your focal length. What is V? Look at the board, what is V?
The image distance from the
Image distance. This is
distance.
object distance. This is
Focal length.
okay. It looks very similar to the formula that we already learned. Yes, but there is a difference.
Plus.
One
Plus,
is plus.
plus one.
Yes, this is minus. Remember, it is going to be minus. How will we remember it? I'm just giving you a very simple hint. Please listen to the hint that I'm telling you. Now, what is it? We are talking about lens. L. Hannah, L for lens. Okay. L is like a minus. So this minus will come here. Remember it that way. Okay. Mirror formula, M is there, therefore it is plus. Okay, for lens, the down part will look like a negative sign, so therefore it is. You remember that? Do not make a mistake. Now when we are doing our sums, please be careful whether it is mirror. Is that okay, children? You remember that? Negative sign. And for mirror, it is going to be a positive sign. Now there's another thing, if you look at your textbook on page number 155, we are also talking about magnification. You remember what is magnification?
Yes, ma'am. Minus p by u.
What is magnification?
Minus p by u.
What does it tell us?
And the times by which the object is enlarged.
Image is it?
Sorry,
Okay, image. Suppose I say this is a convex lens and let us say this height. Okay, this is the height of the object and I'm talking about the height of the image. See how I'm shown? HO. What is O?
Height of the object.
Object. Okay, so this is on the measurement which is perpendicular to the principal axis, right? It's not along the x-axis. So this is H1. This is H1. This is your
Height of
image.
the image.
Suppose I say this is 2 centimeter and I say this is 6 centimeters. Is it magnified or is it diminished? How many times is it increased? Did you see that? So how do we get it as? It is H dash upon H0, which tells us that it is magnified. Is that okay? Did you understand? So it is always H dash divided by H0, which is going to be your magnification. So what does magnification tell us? It tells us how
How
many
big
times is your, the image form. Is it bigger or is it smaller or whatever it is? Correct? Did you understand? Look at your textbook, everyone. Page number 155. Last part. Put a tick mark there. You've already written about the formula. Okay, go on to the next page. Magnification formula, which is going to be H dash divided by H0. Okay, now, there's another thing that you will remember. If you look at H dash, let's talk about H0. Okay, that's the height of the object. It is above the principal axis. Okay, so it's going to be taken as positive or negative?
Negative.
Above.
Positive.
Your height is always from the floor.
And that is positive.
Positive. Now for height, we are not going to say left side or right side. Above it measuring height, it is above the principal axis. So now this object is present above the principal axis. So H0 is going to be positive. Now what about H dash?
Negative.
Because it's below the principal axis. So H0 is going to be negative. So your magnification will
And
be,
magnification will be in the minus.
yes. So your magnification will be -3. Did you understand? Why? Because this is a real image. Because it's a real image, it is formed below the principal axis and therefore this is going to be negative. Is that okay? Right? Now, I'm giving you another example. Suppose it is, look at the board, a virtual image. Correct? If it is a virtual image, it is above the principal axis.
Positive.
That will be positive. Object is also, height of the object is also positive. Height of the image is also positive. So the magnification will be positive. So if magnification is positive, it means to say that it is a virtual image. If it is negative, then it is going to be a real image. Is that understood? These concepts you should understand very clearly. Otherwise, you'll once again mess up. Okay? I'm reading out magnification. Are you ready with your textbooks? Okay. The magnification produced by a lens is similar to that of a spherical mirror. And it is defined, what is the definition? Underline, ratio of the height. Look at your textbooks, everyone. It is the ratio of the height of the image. Okay, that is your H dash. And the height of the object. Height of the object, how do we show? It is H0, O for object. Okay? Or HO you can write. Magnification is represented by the letter N. If H is the height of the object, here in the textbook they have not given us HO. Right? I have written an O because it's easier for us to remember that it is the height of the object. If H is the height of the object and HI, or you can say H dash, is the height of the image given by the lens. Then the magnification is given as m is equal to what?
H
H
dash
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 divided
upon
by Is that okay?
Yes, ma'am.
Look at the last few lines there. Magnification produced by lens is also related to object distance and image distance. That can also be given as V upon U. So this is also equal to V upon U. Okay, so this formula also can be used. Suppose they have given you the height of the image, height of the object, and maybe this is not given. If these three are given, then the other one can be found. Out of the four, any three will be given and any one can be asked to find. Is that okay? Here, let's take up. Okay, come on.
Sometimes ma'am, they will directly give the magnification also, right?
They can give you the magnification. Suppose here, look at the sum. I can give you only this part. Suppose I give you the magnification. I am giving you the height of the object. You may be asked to find out the height of the image. Okay, out of the three, two will be given, one can be found out. Right? Come on. Take down one sum. Ready? It's given in your textbook, but I'm going to dictate for you to understand how to pick out the points from the sum and how do we read it. A convex lens has a focal length of 10 centimeters. Convex lens has a focal length of 10 centimeters. The object of height the object of height 2 centimeters is placed at a distance of 15 centimeters. If you miss out something, whatever you hear, you write. It is placed at a distance of 15 centimeters from the lens. Okay. Find the image distance, nature, size, magnification. Is that okay? So what do we, by reading the sum, what is the first thing that you can understand?
Focal length is 10 centimeters.
No.
That's a convex lens.
What are we talking about? It's
Convex
a convex lens. So immediately somewhere draw a rough diagram because I know it's going to be a convex lens. Right. What else have they given?
The focal length 10 centimeters plus 10 centimeters.
So it is going to be focal length this side or this side?
Right hand side.
Right. Okay, so here is F and this is going to be 10. So the distance from here to here. Okay. Then what else is there?
The height of the object 2 centimeters.
Where is the object kept?
Left hand side.
On the left hand side. Height of the object, that is H O, is 2 centimeters. So is it going to be positive or negative?
Positive.
Why?
Because
The height of the object.
It's
minus
above
the
the principal axis. So obviously it is going to be plus. Okay, so I have got some information now. 2 centimeters. F is equal to 10 centimeters. What else?
The object distance
How much is it?
minus 15 centimeters.
Object. Correct. At what distance is it? Read the sum without
Minus
read. Don't wait for somebody to supply the answers. Minus 50. Okay, so here, from here to here, it's 15 centimeter. But when we take it down, we have to write it as minus negative 15. We are going to write it as negative. Is it here? 2 centimeter tall, convex lens, focal length is 10 centimeter, distance is 15 centimeter. Now what are the things that we have to find out? Required to find. I have to find out V,
V
I have to find out the size. Size means what? I have to find out H dash. I have to find out whether it is big, small. Then I have to write down the position, okay? And of course, there's a magnification also. So these are the things.
So we don't have to draw the diagram in the question.
It is easy for you. You can always write it, draw a rough figure. Okay, with pencil, if you draw a rough figure, it becomes easy for you to understand. Is it difficult? Can we do it now? Which formula shall we use? First thing is we are going to use this. Come on. Okay, so you're going to write down your formula first of all. 1 upon V minus 1 upon U is equal to 1 upon F. I have to find out V. F is what? 10 plus 1 upon U is negative. Okay. Be careful about the negative side, okay?
When V is equal to 30.
Is it positive or negative?
Positive.
False.
Yes, I'm doing
Will it be positive or negative?
Positive.
it.
How much is the LCM? Yeah, 30.
30. And the height of the image will be found from the magnification.
Yeah, from the magnification, yeah. First you will have to find out, then you'll have to use this formula. You know U, V, and I know my H0. Then you will find out H dash. There's no need for you to do all that. You can just find out M is equal to V by U. That way also you can.
Then
V is equal to 30.
connection.
How much is this? That is 56. Okay. So, 3 times. And there is negative. Minus 30 and
3 minus.
Q minus
3 minus 2 by 30.
Did you get plus?
Yes. Ma'am, magnification negative.
Okay.
Ma'am, V is equal to 30.
Is it positive or negative?
Positive 30.
Anybody who's having a problem with this step? Did you understand? So you will get it as 30. Okay, 30 and 10, it goes 3 times. This becomes negative. 15 and 30 goes 2 times. So that is equal to 1 upon 30. Therefore, your value of V is equal to 30. Correct? So V is positive here. Then we need to find out the magnification. Magnification formula is V by U. So V by U, right? V is equal to 30. It's positive. U is minus 15. How much is it magnification?
minus
It's
2.
minus 2.
Am I getting my
It's okay, either which way. Okay, magnification is negative 2. Okay, Kaushik? What does this 2 indicate? What does the number indicate? Is it bigger or smaller?
Bigger.
It's larger. Okay, it's 2 times. And what does the negative sign indicate? Inverted. It is a real image. Okay, so here when I say what is the position, we know size, we can find out. We know that it is going to be real and inverted. Why? Because there is a negative sign here. This negative sign is indicating that it is real and inverted. Magnification is 2. What does it tell us?
4
That it is going to be 4, double the size. So if your h0 is 2, therefore your h dash is going to be 4 centimeters.
Minus 4, na?
It is going to be negative because it's going to come below the. Okay, so the moment I have said that it is real and inverted, it obviously shows it is going to be negative. So this is, you are going to take it as 4 because it is going to be inverted. Yes. You can do magnification into 2 times, either which way you can do. Is that okay, Chiku? Did you understand? So how we need to pick up the points which is given. Look at your textbook, page number 156. Did you see that example 9.4?
Yes, ma'am.
Okay. I have not given it in the same format. I have changed the wording. I have changed the format, but the numbers are the same. Now I want you to underline what are the important points that you have picked up from the sum. Okay. First thing, 2 centimeter tall object. What does it tell us?
Plus 2 centimeter of height of
H
object is plus
O. Okay, that is your HO. They will not tell you, but you have to know what it is. Right? Next thing is convex lens. Underline that. Focal length 10 centimeter. What do we infer? F is equal to
plus 10 centimeter.
positive 10. Right? Then object 15 centimeter.
Negative.
So U is
Minus
negative. Okay, and then of course the rest of it. Did you understand? Okay. Now take down one more. Once again, this is a sum which is given in your textbook, but let's not peep into the textbook. Let's do it on our own so that we understand how it needs to be done. Ready? A concave lens having a focal length of 15 centimeters, having a focal length of 15 centimeters, forms an image at 10 centimeters away from it. Where is the object placed? And also find what is the magnification produced by the lens. Okay. Try not to look at your textbook. It's given in the textbook, but everybody will try on your own. Like how I helped you out in the first case. Read the sum, understand whether it is convex, concave, what is given, Come on, do it. Okay, first of all, try to imagine which lens are we talking about?
Okay.
Concave. The moment we talk about concave, there are three things which is immediately for us. U, V, F, what will it be?
Negative.
All of them will be negative. So this is negative, this is negative, this is also negative. What is the focal length?
Minus
15. So here focal length is 15 centimeter. What else is given to us?
The image distance
Image.
minus centimeter.
Yes, image is 10. I've already put a negative sign there. Yes. And U is something that I have to find out. But I know that the answer will come in negative. Correct?
Yes.
We know that it will come definitely in negative. Okay.
Yes, ma'am, got it.
Then what else is given? Nothing else.
And we have to write it.
Yeah, magnification also. Magnification, see, once you know all these three things, look at the board, magnification you can find out. U upon V, you will get magnification. Okay?
Ma'am, magnification is in decimal.
Sometimes you may get
I got
it.
1.6.
Let's do the first step. Let's do the very first step, find out U. And all working should be done on the same page. Boys and girls, listen to me very carefully. All working should be done on the same page. Even in the board examination, we believe that the working should be done on the same page. Otherwise, we don't give you marks. How much? Minus 30.
No, ma'am,
Minus
Minus 6.
yes. Minus 6. The image, sorry,
Object distance. Minus 6.
Minus 6.
Minus 3.
Do again.
Ma'am, it's minus 6.
Okay. Minus 1 by f is equal to. You
Very
have to find out U, na?
Yes.
So it is also change the sign 1 by U is equal to 1 by f.
1 by u equal to 1 by v minus. Ma'am, you don't have to find the height. But we don't have to find the height.
Magnification.
Ah.
Okay, now look at the board.
सही कर रहा हूँ.
Look at the board.
It's all good.
This is what I need to find out.
As it's 0.3 plus v.
What point?
The magnification.
First you find out U. First you find out U. How much did you get?
U. U. U 30.
You need to change the sign here. Okay? You need to have a
Minus.
So it is 1 upon U. Minus 1 upon F. This will be positive when it goes there. It becomes negative.
0.66. Ma'am.
Yeah, why are you struggling? Okay, let me just keep it as it is. 1 upon F. And this becomes 1 upon V. Okay? You can make it as positive. If you want to make it as positive, this becomes negative, this becomes positive. As simple as that. You multiply the whole equation into negative sign. 1 upon U is equal to 1 upon minus F. This becomes 1 upon V. Now you substitute.
Ma'am, positive.
Q. Then your answer will come in negative, obviously. Or if you use like this, you will get it as 30, which means it is minus negative, minus 30. I know which way you can do.
Magnification is decimal.
One by
Sorry,
three.
yeah.
That's fine. It's perfectly all right. What you have done is perfectly all right. So how much have you gained?
1 by 3.
So
I'm using the 10 by 3. 10 now 40.3. So 1 by 3 is 2.3.
इसको 0.3 और 0.3
Did everybody get it as negative 30?
Yes, ma'am.
Okay, very good. Now we have to find out our magnification. M is equal to E. Yeah. So how much is it? Did you get it as 1/3?
Yes, ma'am.
1/3 is equal. Recurring.
Plus 0.3.
So it shows, is it magnified or is it
Diminished.
magnification you're getting as 1/3? Okay. What's okay, what's this? So magnification you get it as 1/3. That means to say the image formed is 1/3 the size of the object. Always remember, in a concave lens, your image formed will be 1/3 the size. It will be much smaller than that of the object. So that's why I said whenever you draw the diagram, we definitely know that if this is your object, okay, your virtual image, H dash, will be smaller than. Okay, so it's going to be 1/3 the size of your object. Got it? So immediately you can cross check whether your answer is correct or not by looking at the sign and looking at the diagram. You go, madam. Go. If you want to go home, go. Tell me, Amma. Right. Come to the last page where we have a couple of more sums on page number 160, 160. There's a little bit which is still we have to do, that is regarding, have to talk about your power of a lens. Okay, before I go on to that, a couple of more sums so that you are comfortable with it. Shh. Question number 11. No, we will do it right now. Shh. Question 11. Write it down. 11, page number 160.
Almost the same.
Yeah, because it's 10, 30. Sometimes they may give you mirror, sometimes they may give you lens. Be careful.
So we have to draw the ray diagram.
Here they have asked you to draw, but don't draw. Do it in the form of a sum. Okay, can you take it down as homework otherwise?
No, ma'am.
Yes, ma'am.
Because they have asked you to draw the ray diagram.
Thank you, ma'am.
So it's the same thing as what we have done.
Minus
10 and 3 and 30, everything will be the same. Okay, what about 10th one? Let's do the 10th one. Shh. Okay.
Easy.
Mira, I'm going to ask you now. Come on, you also.
Yeah, ma'am.
Sum number 10.
11th वाला
11th तो मैं बहुत कर देना.
okay
And let's do 10th one for. Okay. I'll ask one of you to stand up and tell me what is what. So each one of you think individually. Positive, negative, F, C, U. Why are you people searching now? What are you searching in his book? I said sum number 10, no? It's here. Basic things only we do not know, whether it is diverging or converging lens, diverging lens.
Convex.
Five centimeter in length will be the height.
Read and understand. Try to understand the important points and then like yeah.
अबे read है
See, that is where we make a mistake, whether it is U or V, whether it is converging or diverging. See, all these details they will find.
And we don't have to find them.
Don't draw the diagram.
We don't have to find the diagram.
Whatever is given. Got it? Okay, at least some things. Everybody has to make it.
draw the diagram.
No, no.
Draw the ray diagram.
3 by 50.
पर नहीं करना है ना बोला तो
3 by 50.
हाँ, it was 1 upon V is equal to
3 by 50. So 3 is equal to
do. Working on the same page. Nobody is going to look behind and find out the work. That's to be done. Yeah, you are right. Carry on.
sketching.
Many of you are getting it.
Ma'am, 16.6. Minus 16.6. Minus 16.6.
You revise and come now. U and V, what is V, what is U? Whole lesson is getting over, you're still stuck with U and V.
Ma'am, I'm asking for value of
Yeah.
some object being defined.
Okay, 1, 2, 3 of them have got the correct answer. Yeah.
the point.
How much did you get, madam?
E upon U.
Point में आया।
How much did you need? Need how much did you get? Yes, correct. So that is the centimeters per value. The units. Positive or negative? 16.6 positive or negative?
Negative.
So it definitely you can make out.
What do we use? Like the LCM.
It's negative, this is positive.
Goal.
So that will be
Because negative.
Focus हमारा right hand है.
Plus 5. So three upon P. I got that before. But ma'am, it isn't. So P is equal to 3 upon each answer.
Is it positive or negative?
Positive.
It is positive.
Negative.
50 by 3, you won't get a negative sign there.
Cancelled away.
So positive, it is positive.
Negative बोला था तो
Positive.
हमारे दिमाग में.
देखा
अबे हाँ तो एडिशन हो गया
So
Now
what,
that 116.6.
so what do we have? An object of 5 centimeter in height. Okay, 5 centimeter. And you have head is 25 centimeter.
Positive 3.6.
0.6 Pushpa. Magnification.
Focal distance.
We don't have to put the magnification.
If it is not as well, then it is.
Magnification rate होगा. हो गया ना measuring point
But then value
You
is
will
negative.
be your object is always placed on the
And we solve it another because they had to the position.
It's positive. So therefore, it is a
Ma'am, I actually got it right, but I didn't.
Don't worry, children, sometimes you may get it in points.
Goal. 0.6 type.
अबे यार
Okay? Done? I think I have to find it. Yeah. How do we do अरे गवार Okay, done. Okay, right? Done. Now, a couple of sums I'm giving it to you for homework from your volume. This is your volume 2. Volume 2. Okay, if you're, I don't know, you may not have, but just take it down. Shh.
How will they find the size and position? Oh, magnification.
UV, you know edge. So the other edge you can find out.
वो तो height ढूंढना पड़ेगा.
focal length पास ही है.
And position would be left hand side.
On the opposite side. Okay. Are you ready? Homework sum. All of you take down. Homework sum.
Second number.
This is your volume 2, right now. No, don't take. Just make a note of it. Volume 2, page number 47. Homework. Okay, solve the following is given. Some of them I have not yet done because I'm going to do power of the lens in the next class. Then page number 47, there's something written as more for practice, right? Under that you have got your sum number 8. Okay, go on to page number 48. Sum number 9, 8, 9 and 10. Because all of them are for lenses. Some of them are convex, some of them. So Anil, what is the homework? I'm asking it.
Page number 47, question number 8.
And? Busy talking. How many sums did I give you?
3.
You solve the following.
Yeah, more for practice is given.
Solve the following.
No, you can't do all that. I'm not telling you.
It's not to be done, right?
You cannot do, I have not done.
Let's do question.
And it's capital is given.
Page number 47. Page number
We are talking now about the power of the lens. You must realize that a convex lens is converging. Okay? And a concave lens. A concave lens is a diverging lens. Correct? So when we say it is converging, we are talking about rays of light which will converge. Suppose you talk about this as a principal axis. Okay, it is meeting at a point. Now when we talk about the power of a lens, to what extent does it converge? Correct? That depends once again upon the thickness of the lens. Sometimes you may have a lens which is pretty thick. So here we find that it is converging. This happens to be your f and this is your focal length. But if it is a very thin lens, right? Once again you notice that it is a convex lens. But these two lenses definitely are different because this is a thicker lens and this is comparatively thinner. So if you talk about the power of a lens, it tells us to what extent it can converge. Have you followed? Okay, to what extent it is converging. So if you are talking about a ray of light which is falling on a very thin convex lens, then we find that it is converging, but it is quite far away from the optical center. Did you understand what I'm saying? Did you notice in this difference in this? So here you find that this is your focus and this is your focal length.
So ma'am, focal length is
So focal length,
inversely proportional to thickness.
yes. So if the thickness of the lens is less, then focus is taking place or the focal length will be far away. That means it has got a longer focal length. Correct? If the lens is much more thicker, then the converging power is more and therefore you find that this focal length is going to be shorter. Suppose I say the focal length is, let's say, 3 centimeter. Here it's definitely not 3 centimeters, it may be 9 or 10. Okay? So what is the power of a lens? The power of a lens for a converging lens, now right now I'm talking about a converging lens, is to what extent it is capable of converging. Have you followed this? Okay. Now we use the same concept and apply to a diverging lens. So when we are talking about a diverging lens, suppose this is your principal axis. Okay. We know that a ray of light which is parallel to the principal axis after refraction has a tendency to move away. So it is a diverging lens. But when we extend this rays behind, okay, it appears as if it is coming from a point and that is your focus. Okay. So when we talk about the power of a diverging lens, it is to what extent it is capable of diverging the ray of light. Have you all followed?
Yes.
Is that very clear?
Yes, ma'am.
Please take down definition.
Power of the lens.
Power of a lens. Ready? The degree of convergence, the degree of convergence or divergence of light rays achieved by a lens or got by a lens is expressed in terms of its power.
Of its power.
Of its power, power of a lens. Okay, power is, this is your formula. The formula for power of a lens is,
Our MCAP.
right, P is equal to the reciprocal of the focal length expressed in meters. Okay, all this time we were talking 10 centimeters, 25 centimeters, but when we are talking about power, we have to express it in meters.
The reciprocal of
So write down the formula. Okay, is defined as the reciprocal. The power of a lens is also defined as the reciprocal of the focal length expressed in meters. Okay, so the unit of power is given as capital D. This is the unit. What is D? It is diopter. 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 Okay, and remember that focal length should always be expressed in meters. Okay. Come to page number 150. 157 of your textbook. 157. Anybody wants to read? Voice behind, you have a textbook there? Read. Power of the lens.
Power of the lens. You have already learned.
Are you ready with your pencil? Because you're going to mark some important points there. Ready? Read.
You have already learned that the ability of the lens to convert or divert light rays depends on its focal length. For example, a convex lens of short focal length bends the light rays to large angles by focusing them closer to the optical center.
1 minute. 1 minute. Go through the question. Go through that statement once again, very carefully. And look at the diagram that I've already put up. Read that statement and look at the diagram. Did you understand? It is capable of bending it through larger angles such that the focal length is closer. So that the focus is very close, and therefore you have a shorter focal length. Okay? So a lens which has got a very short focal length has got a greater power. Why? Because this is inversely proportional. If f is small, p is more. Did you notice? Okay. If f is longer or it is larger, then obviously p is going to be smaller. So p and f are related. There's an inverse. Right? D.
Similarly, concave lens of very short focal length causes higher divergence than the one with longer focal length. The degree of convergence or divergence of light rays achieved by a lens is expressed in terms of its power. The power of a lens is defined as a reciprocal of its focal length. It is represented by the letter P. The power P of a lens of focal length F is given by P is equal to 1 upon F.
F. And please write it in your book also. F should be expressed in meters. Come on, write it in your textbook. Okay? F should always be in meters. Okay. And did you mark the definition which I have dictated right now? Did you notice? In your textbook, did you underline? Yeah. Go to the next page.
The SI
Yes,
The
SI
SI
unit.
unit of power of the lens diopter. It is denoted by letter D. If F is expressed in meters, then power is expressed in diopters. Thus, 1 diopter is the power of the lens whose focal length is 1 meter. 1 D equals to 1 meter. You may note that
1 minute, 1 minute, 1 minute. Okay, now look here. We have seen the formula. Okay. SI unit of P is diopter. Suppose I say power is 1 diopter. It means that your focal length has to be in
Meters.
how much?
1 meter.
1 meter. It has to be 1 meter. Therefore, we can say 1 diopter is equal to 1
Meter
meter inverse. Did you get it? Next class. Test.
I think 26 was
I'm going to give you a test.
no, 26
I don't know about all the tests that I understand.
Science में
And these sums for homework and plus test on this.
Next week हमारा science है. हाँ, ये भी है.
हम लोग बोलते हैं कि हम लोग जब बोलेंगे
I need one.
You don't have any class now.
क्या चलाते हैं? नाम के पास नाम ही नाम कूल हो गया था या फिर दवाई है क्या? मैं बोल दूं इनको
चलो भाई ताकि
मैं बोलूं इनको से जाने दो सीधे रहा ये रहा
अभी चालू हो गया।
60 बोल रहा है 60 भी है
मेरा भी आया है, तुम लोग साइड में के जब से मार दो। हाँ साइड में
अभी?
मार।
लोग
अबे
किधर जा रहे हो?
ये चालू था।
जा रही है
फिजिक्स में बस हाँ भाई
गवाह